Hello, everyone, and welcome to what is our last session of the 22 school year for our music technology community here in the Georgia Department of Education. I'm really excited to have another guest this month on the sessions, and this is Dr. Jason Freeman, and he is a professor at the Georgia Tech Institute of Technology, our lovely partners down in Atlanta. And if you didn't know that Georgia Tech had a really cool thing going in music tech, you really need to check out their website and just see how vast this music tech program really is. They might not be the ones that are always churning out the radio hits, but everything that someone needs to use to make a radio hit, these guys know how to make from scratch, which is really, really cool in my opinion. So, they have been doing something really cool with a program called EarSketch that they developed lately, and it is coding in music technology, or using code to build songs and different things. And I'm not even going to do it justice if I talk about it. So I'm just going to turn this portion over to Dr. Freeman and let him tell you what they're doing and why they're doing it, the impetus behind all of this. And I think you'll be excited hearing what all is coming out of this project. So Dr. Freeman, can you tell us more about coding with music technology?
Yeah, absolutely. And thanks so much for having me on the podcast here. I'm very happy to be here. Uh, coding has been and music have both been lifelong passions of mine. Going back to an elementary school student when I was young and kind of writing on an Apple II computer and learning how to program in BASIC to play simple melodies and things like that. And I think there's always been a natural connection between the two. The way that musicians think logically, the way that we plan ahead, the way that we execute things, the way that we repeat and vary patterns as we move through creating or performing or improvising music has a lot of parallels in terms of how we think in terms of computation. And so there's always these natural kind of pedagogical connections between these two fields. But there's a lot of other connections as well in terms of how we use coding in the music industry today. But before I get any further into that, I wanted to lay out a few important terms. And I think it's really important to understand the difference between coding and algorithms and computational thinking, which is a term that we hear a lot in education these days. So coding for me is the actual process of writing the code, typing something into a screen, or those graphical programming languages as well. But the actual steps where you're telling the computer kind of step by step what to do and specifying that out. And that's a really important skill for students and really for everyone to have that familiarity with how programming languages work and how to use them. But that's not the end goal when we're talking about learning computing and the reason that we do it. That's like the equivalent of learning how to tune a musical instrument as opposed to how to play it. You understand the mechanics of how it works, but we need to go further. And when we go further with coding, we really start thinking about algorithms. And algorithms are the recipes where we explain to a computer how to do things. And this is where the thinking starts to get more abstract, the same way that when we think about music, start thinking about musical structure and form and all kinds of other things, and counterpoint and things like that we start getting more abstract in our thinking. The algorithms are where we get more abstract with the code, where we're organizing things into things that can branch and can change and can repeat and do all these things based on internal logic that's represented within them. And all of this points to this broader skill of computational thinking, which I think is really a core 21st century skill that every student needs to know. And the point here is not that every student is going to go work for Google and start, become a software engineer as a living, but that computational thinking is this very basic, fundamental kind of cultural literacy that we need in the 21st century, because computing is so central to everything that we do in every discipline. And so this is a way of thinking that may or may not even kind of continue to find its way into writing the specific code and developing programs, but understanding how a computer thinks logically and how we kind of work with computers in this algorithmic mindset, and making sure that we can think in that way as well. And this is really important because computing is so central to so many aspects of our lives. When we when we read a news feed on a social website, to understand the algorithms that are influencing what is actually shown to us, and the biases that can be introduced by that is really important. Or when we work with music technology to understand, or when we open up Spotify, to understand how those recommendations are being generated for us, and understand how that can impact the ability of new artists to have their music discovered, and create all kinds of effects that influence in both good and bad ways how we discover new music and how new artists are discovered. And then also how we actually make music itself. So much of what we do when we create and perform music now is mediated by computers, working in a recording studio or working on our mobile phones with production apps, using plugins that add effects to our sound or transform it in different ways. And then kind of entirely new ways that computers, particularly through machine learning and deep learning, are changing the ways that we think about music composition and music collaboration. Let me stop there and see if you have any follow-up questions. I can go through I can talk about this all day.
I just really like that you took the idea of like coding as a specific language, which is already a skill that I'm not extremely competent in as a music technology teacher. I've seen you guys do this and I'm blown away every time. And I've experimented with EarSketch just a little bit, but I love that you're taking this to the next level of like the algorithm side of it and problem solving. Like there's not one way, I'm hearing you say, to get to the final result. You've got to work your way through this problem solving. And I think that's an essential skill in a music studio for sure, and an essential life skill that you're talking about here as well. So I'm really encouraged by being reminded that like this is a good path to follow in order to achieve those types of skills. I think that's vital. We don't just teach music. That's a great side of it. But if we can teach students to be better problem solvers through music, I think that's a great thing.
Absolutely. Yeah, music is such a powerful hook to engage students. And we want to teach students musical skills in and of themselves. And those are important and they have value. But it's also a gateway to teaching students about creativity and leadership and collaboration and problem solving and critical thinking and computational thinking, and this whole set of skills that students can learn through music. So music may be the initial thing that kind of motivates them in the context in which they learn it, but then they can transfer that knowledge to other domains as well.
Can you give me a little bit more concrete definition for me to really solidify around computational thinking?
Yeah, that's a tough one because it's been defined many different ways. But I think when we talk about computational thinking, we're talking about a kind of a logical approach to working through problems that includes kind of understanding and designing algorithms or processes to solve them.
So would you say that this is the new version of the scientific method in a way that we're creating these algorithms to solve problems and testing them and seeing if they work, and then
it's another methodology that's complementary to the scientific method.
Okay.
Right. So you could use all of these tools within the context of the scientific method. If you have a problem that you want to solve, there are ways to use computational thinking to develop methodology to look at it. Like one of my colleagues at Georgia Tech is really interested in melody and how melody has changed over time. And she works with big databases of popular music, like the Billboard charts, basically, looking at analyzing the melodies and songs over decades and trying to chart how that, develop algorithms that analyze what those differences are. They crunch all those numbers. And this also gets into a third thing. So we talk about the scientific method, talk about computational thinking. The other part that's really important is data science and data literacy. And the ways that we use huge amounts of data in the world today for almost everything. A lot of those examples I was talking about before come down to not just computational thinking and algorithms, but also the data that those algorithms are working with. And maybe I could share a concrete example with you real quick. I'm going to go ahead and share my screen. So this is a system called MuseNet. I'm not sure if you've seen it before or not. But this is a deep learning initiative, kind of the cutting edge of machine learning. And this is an example of what it can do. So it's looked at gazillions of kind of MIDI renditions of popular music, and it's trying to now compose music based on what it's learned from that data. So in this demo, I can choose a style, Chopin, Mozart, Rachmaninoff, so on, and a starting point. So this is starting Mozart's Rondo alla Turca, the first couple measures or whatever, and then continuing it it's continuing it in the style of Chopin. And I just realized I did not turn on the audio sharing. So give me 1 second to do that so that you can hear this as well.
I think my mind is about to be blown right here.
All right.
I'm really
so
excited.
I'm just going to go ahead and hit the play button and we'll see what happens here. Okay, I'll stop it there. And then we can start with a different starting point, like Adele, in the style again of Chopin. Okay, maybe that one's not as convincing. There's still some room to grow here.
Maybe Adele's been studying Chopin. I'm just saying.
Maybe, but the point is, it's easy to pick these things apart as not being as good as you or I or anybody else who composes kind of the old-fashioned way. But that's not really the point here. The point is, this is a fun demo, but where the technology I think is really going is in ways that we can create new kinds of collaborations where computers are supporting human creativity and not trying to replace it in any way. And one of my favorite examples of that is a recent project from Google called Piano Genie. I don't know if you've seen this or not. It's
kind of seen that Google the Google Doodle they had for the Bach thing where it would.
Okay, yeah. So this is from the same research group that did the Google Doodle for the Bach, with the 4-part harmony with the chorales. And so they analyzed a whole lot of piano music and then wanted to make it some experience for someone to be able to play piano music who can't play piano at all, instead of sitting down and playing Mary Had a Little Lamb or whatever. So you've got these 8 keys here, which are the 8 number keys on the piano. And if I play them, you'll see it's not just playing 8 notes in a row. It's using the machine learning and this data analysis of all this stuff to try to figure out a way to play something in a pattern. And it gets interesting when you start playing kind of gestures up and down. When I play the same keys, it's not playing the same notes. This isn't mapping onto kind of 8 notes of a diatonic scale. It's mapping to the 88 keys of a piano. And there's a hardware interface that they built for this too that makes that looks more like a piano, but only has the 8 keys on it.
Yeah.
So you can really kind of play around and start thinking about gestures and how those gestures and the contours of things move up and down and the rhythm and all of that kind of stuff without having to worry about the actual notes, and letting Piano Genie fill in something that's plausible. And this is an idea that's been really common in kind of computing and music for a long time. The notion that maybe, again, not that we're going to replace the 10,000 hours that you spend learning to be an expert at an instrument, but that we give some semblance of an experience, a creative experience, that can be achieved by combining some kind of expressive input that's at a kind of a lower barrier of entry, along with the intelligence of the machine to try to kind of fill in those gaps and build in the low-level content.
That is awesome. Okay, so I want to close this session with this. Can you give me your elevator pitch for just why should our music technology teachers in the state of Georgia really care about coding? The 30-second version.
30 seconds. I think that Music technology and coding are deeply intertwined with each other, and it's hard to fully understand one without the other. And coding and computational thinking are these core 21st century skills that we have this unique ability to inspire students to pursue through those connections to music technology.
Fantastic. Thank you, sir. We'll be back on another day with session number 2 with Dr. Freeman. I'm super excited about this. I think you are going to love it. Hope you guys have lots of questions. If you do, put them in the discussions on this forum, and we'll be able to hopefully get Dr. Freeman to answer them if they're not something that other teachers around the state can already answer from their experience with Dr. Freeman.
Absolutely.
So, thank you for your time. Look forward to the next version where he's actually going to show us more about how to actually do the coding and the music technology. See you soon.